So here's what I expect in a warmer climate for the bulk of the forest in Minnesota, which is mostly in the north. Jack and red pine would decline or maybe even disappear. We might have to pick a new state tree if red pine goes away. Norway pine is the same as red pine. That's our state tree. The spruces would decrease. Paper, birch, aspen, tamarack would all decrease in abundance. In northern Minnesota, the maples would increase in abundance. So would white pine. It's interesting that in northern Minnesota, white pine's actually near the northern edge of its range, and right now it's a little too cold for it. So a warmer climate might do better in a warmer climate. But basswood and the oaks would be able to move in and become more abundant as well. They're very limited by cold temperatures right now. And a lot of species could migrate in. Hemlock and white oak and black cherry in the boundary waters. Black cherry and white oak are already here in southern Minnesota, and southern Minnesota could end up with tulip tree and sycamore and things like that in the future. And wildlife, of course, follows the trees, right? All species of wildlife live in vegetation, or they eat another animal that lives in vegetation, right? So animals are totally dependent on what types of trees there are. And some of the winners would be deer in a warmer climate, right? We all know when we have a harsh winter, there's a die-off of deer. When harsh winters don't occur, the deer population increases. Wolves, of course, in northern Minnesota right now, they eat moose mostly. They can switch to deer very easily. So if the moose disappear and the deer take their place, the wolves will be just fine. Wolves don't care about temperature at all. Before settlement, wolves lived all the way from Texas all the way up to the tundra. All they care about is whether there's either deer or moose or caribou, some sort of ungulate that they can eat. But what's really going to be a loser in Minnesota is the lynx. You know, it's really a boreal forest type of animal. It's not going to live in an oak forest or on a prairie. Black-backed woodpeckers only live in spruce forests. Moose, of course, can't withstand the heat. You know, you get a 40-degree day in the middle of winter and they've got heat stroke. Their fur is such a good insulator, they have to go in the shade during thaws in the winter. And boreal owl, I don't think you can convince a boreal owl that it should live in an oak forest when it lives in a spruce forest now. You won't be successful if you try to do that. Forests also thin out in a warmer climate. It gets warmer, there's more evaporation. The soil will be drier and there'll be fewer trees. The trees will compete with each other. Some of them will die. Each tree, the surviving trees will get bigger root systems so that the tree will still get the same amount of water even though it's a drier soil. That's just the laws of biology. A warmer climate, if it makes the soil drier, is going to thin the forest, and forests will tend more towards a savanna type of structure rather than a dense forest, unless there's so much extra rain that it compensates for the evaporation in a warmer climate. Right now, it doesn't look like that'll happen. It looks like, from the slide I showed earlier, we're headed towards warm and dry summers, so maybe more towards a savanna. Climate change doesn't only change how warm the temperatures are. It also changes storm frequencies and fire frequencies. And the type of forest that you get depends on fire frequency. Pine forests live in areas with a medium fire frequency, so do oak forests. If there's no fire, then you get some late successional thing. It could be maple in a warm climate or spruce and fir in a cold climate. And if there's very frequent fire, then you get savanna, which is scattered trees in a grassland. And we do expect that if the warm and dry scenario develops, of course, vegetation will dry out more and there will be more fires, and that will help push things towards a savanna. And we're not sure if we've seen the increase in fire frequency yet, but we've had two really big fires in Minnesota in the last 2 years, Cavity Lake in 2006 in Ham Lake in 2007, as you can see here, and I was actually out on Seagull Lake, which is that lake in the boundary waters when the Ham Lake fire ignited. And I happened to be there with Gus Axelson, who is the managing editor of the Minnesota Conservation Volunteer magazine, and Lane Kennedy, who is a professional photographer. And we were working on a story about global warming because you can already see the maple invading spruce forests in the boundary waters. So that's what we were going to cover. And then halfway through our wilderness trip, this fire ignited. And then we were trapped there in heavy smoke for 2 or 3 days as the fire came towards us. And we were in a place where we just couldn't get away. But at the last minute, the fire changed direction, and we were able to get out. That ball of flame right there is Wilderness Canoe Base. And that's Voyager's Canoe Outfitters right there. It's not as big a ball of flame because they had sprinklers. And that's where our cars were. We didn't know they had sprinklers. We were convinced our cars were going to be burned out shells, but then when I got there, the owner of the outfitter had put a sprinkler on my car when the fire passed through, so that was really nice of him to do that. So this is midnight, and we're 3 miles from the fire here, and we didn't even need a flashlight. You could walk around the woods at midnight without a flashlight because it was so bright from the fires. So 76,000 acre fire. So maybe if this trend continues, maybe we're starting to see the increase in fire that we think will happen. This is the Cavity Lake burn of 2006. This is a year later. And that mountain of pink granite there was completely covered with forest before the fire. I don't think forest is going to recover there. I think the climate has changed enough so that it's not going to be the same. It was jack pine for thousands of years. These dead trees here are jack pine. All of the regeneration there is cherry. Not only fires, but storms. Storms, we all know that storms, severe thunderstorms with high winds and tornadoes occur during the summer. If summer is longer, we'll have more storms. This is the path of damage of the big derecho of July 4th, 1999. A derecho is a very severe thunderstorm with downbursts that has a damage path at least 200 miles long as defined by the Weather Service. And you can see this one began in Fargo and went all the way to Maine. And look at the speed. At 1 o'clock, it's in the boundary waters. At 5 o'clock, it's on the east shore of Lake Superior. At 2 a.m., it's crossing Quebec. At 4 a.m., it went through Montreal. It did a lot of damage in Montreal. And at 5 a.m., it ended up in Maine. I don't think you could drive, if you had a Ferrari in a freeway there, I don't think you could drive that fast. I mean, that's incredible how fast these derechos move, but they actually have their own jet stream that propels them forward. And part of the energy from that jet stream going into the back of the thunderstorm bends downward and blasts straight down on the ground. And that's why they do such damage. So these big events will occur more often in a warmer climate.
Is that something that happens more in the northerly latitude?
Well, look, this is a map of frequency right here. They've been very rare in the north, but now we're seeing more of them up there. And that's probably because the climatic conditions for formation of derechos are moving further north. The humid air from the Gulf of Mexico, you need those days with a 70-degree dew point for these storms. Never used to occur in the boundary waters, but now it does. This is a derecho frequency map. This is number of derechos observed in 22 years of observation. And this is the derecho triangle, Minneapolis, Dallas, and Pittsburgh. And so it's a triangle. It's interesting that the Bermuda Triangle is like that. It's an exact complement, but I don't think that has anything to do with it. But it's just an interesting thing I noticed. But this triangle is where conditions for these derechos exist. You've got the hot, humid air coming up from the Gulf of Mexico, mountain range here, mountain range there. And hot, humid air and Arctic air are forced in between the two mountain ranges to collide with each other. Minneapolis has the peak, 21 out of 22 years. But not all derechos are, right? Some of them have winds of 60 miles an hour and some have winds of 120 miles an hour, like this one in the Boundary Waters. This is all derechos, not just the very powerful ones. If one like this ever hits Minneapolis or Milwaukee or Chicago, it'll be $20 billion of damage. You know, someday it'll happen, I'm sure. But look at the gradient here. If the conditions move north and the north woods starts having high winds as frequently as we do in southern Minnesota, that forest is going to be flat in no time, right? Our oak trees down here can withstand a 100-mile-an-hour wind, but a black spruce tree looks like a Christmas tree on top of a flagpole with all the weight at the top.